Hello everyone, welcome to my channel. Let's learn computer science. Our today's topic is network topologies, right? Syllabus reference for S&A 9618. Show understanding of bus, star, mesh, and hybrid topologies. Under that, you should know how packets are transmitted between two hosts for the given topology and justify the use of topology for a given situation. So all the questions will be based on these topics on this topic on network topologies. So let's start with the topic. So what is network topology? What do you mean by network topologies? So it's just a way to connect different computers with each other in order to create a network. The configuration of a network, basically, it is the configuration of the network that defines how the various devices on the network are connected. To understand it in a better way, just think of any house design or the architecture of the house in which you are staying. Every house, it has, rooms, maybe these are bedrooms or storerooms or study room or washroom, kitchen, hall, etc., etc. So they have a particular architecture. Before you build the house, the design of the house is created by the architects, right? They create the design and accordingly the structure of the building is created. Similarly, when you have to connect the computers, networks topologies are just like the network architecture. So a design is created for the network, like where and how a particular device is to be connected with the other devices. So it's a way how all the computers, all the devices, they'll be connected with each other. So network topologies are just the network architecture. Okay. So there are many topologies. As per your syllabus, you need to understand about bus, star, mesh, and hybrid. So we'll cover those only. Let's start with first topology, bus topology, right? So bus topology is very, very simple. So here what happens, a single central cable, a single central cable, we have a single central cable and all the nodes, any device which is connected to the computer network is known as a node. So any node, whenever they have to be connected to the network, they are connected directly to the central cable, right? And each end of this cable are known as terminators. Okay. Now, what is bus topology? Single line connecting all devices with terminators at each end. So all the devices, they are connected to this central cable, and this central cable, it has terminators at both the ends, right? Other computers can read the data being sent from one to another. So if this device has to send some data, it will just send on this central cable and it will be received by all, right? But only the recipient will keep it whom it is actually sent for, right? But all the computers, they can read the data being sent from one to another on the computer because it will be transmitted through this central cable through which all the devices are connected, right? We'll learn about how how the data packets are transferred. But before that, we'll learn about the benefits and drawbacks, right? Okay, so this is bus topology. Now let's have a look at the benefits and drawbacks of bus topology. So let's look at the benefits first. Very simple and easy to implement because all the computers, they just have to be connected with single central cable. So very easy to implement. Requires less cabling compared to other topologies. Cost effective for small networks. Requires less hardware compared to other topologies. Easy to increase the size of the network by adding additional nodes. No complexity in adding more nodes. Even if one node fails, remainder of the network continues to function. No effect of single node failure on other computers, right? If any node, it crashes or it fails, then rest of the network will work fine, right? So these are benefits. Now let's have a look at drawbacks. Now, if the main cable fails, the whole network goes down because all the computers, they are connected to that central cable. So if that cable fails, then network is down. The performance of the network deteriorates under heavy loading. So everybody will start sending the data on that single cable through which the communication happens. So if heavy load is there, then performance will be deteriorated. The network is not secure since each packet passes through every node. As I said earlier, the data can be received by all the nodes because data travels through the single central cable. So security is an issue in this topology, right? Then there are collisions as the number of nodes increases, right? More collisions can happen. Then troubleshooting is difficult in bus topology, right? Very difficult to figure out where the actual fault is. Limited scalability and bandwidth, because more the number of computers, heavy traffic will, result in deterioration of the performance of the network. Now, how the data packets are transferred between two hosts in bus topology. So what happens, how the data actually transferred, how communication happens. So data going from host to host is directed through the central cable. So as I said, in bus topology, every computer will send the data to the central cable, and that is how it is sent to the actual node for which it is designed for, or for which it has to be, by which it has to be received, right? So when any host, they want to transmit data to another host, they firstly check if the bus is idle. They check for the central cable if it is idle. And if the cable is idle, they start sending data packets to the bus, right? So transmission happens through the central cable. So every node, whenever they are ready to send data, they'll check if the bus is free. If the cable is free, central cable, then they start sending data packets to the central cable. Then what happens? Data packets, they travel along the central cable in the form of electrical signals or light pulses, depending upon whether you're using copper cable or you're using fiber optics. The signals, they propagate in both directions along the bus, right? So they start traveling on both sides of the bus. As the data packet propagates along the bus, all the host on the bus receives these signals, right? And each host, they will check the destination address in the packet header to determine if that packet is intended for them or not. If the address matches with their own address, then they keep the packet, they accept the packet, otherwise they just ignore the packet, right? Then there is collisions, there is possibility of collision if two nodes, they start sending at the same time. So collision detection algorithms, they are used. If it is Ethernet, then CSMACD can be used. Collision avoidance mechanism can also be used. Then if the destination host receives the packet without any collision, then it processes the packet according to the protocol and extracts the payload. Payload means the actual data, and the host may then generate the acknowledgement and send back a message that I have received. And once the transmission is complete, the bus or the central cable, it becomes idle again, right? So simple. Firstly, whosoever wants to send the data. They'll listen whether the central cable is free or not. Then they start sending the data to the central cable. Everybody in the topology, every node in the topology, they'll receive it. They'll check for the address in the data packet header. If it is for them, they'll keep it. Otherwise, they'll ignore it. There are collision detection algorithms used upon reception of the packet. They'll extract the data from the data packet, and then acknowledgements can be sent accordingly. And once the transmission is complete, central cable becomes idle again, and it is ready to receive more data packets, right? So that's all about bus topology. Now we'll learn about star topology. Star topology, as you can see in this figure, there is a central server, there is a central computer or server through which all the nodes are connected. These are nodes, right? All the nodes are connected to the central server. So if the computers, they have to be they have to connect to some other computer in the topology, in the network, they are connected and they'll send data via the server. They can't communicate directly to any other computer in the network. However, they can communicate, but via the server. So each end system is linked to the central device in star topology, right? Let's have a look at the benefits and drawbacks of star topology. Data collisions are greatly reduced due to this topology, because everybody, they'll have to send the data to the central server and not to any central cable. So collisions are greatly reduced. More security measures are taken by the server. It is easy to improve by simply installing an upgraded hub. So if a connection is to be upgraded, then this central hub or server can be upgraded. If one of the connections is broken, if any of these nodes, they get crashed or not working, it does not have any effect on the rest of the network. Okay, easy to troubleshoot, scalable, and allows as many devices you want to add, you can add it. Provides dedicated bandwidth to each connected device. So server, they set standard dedicated bandwidth for each of the connected device, so that data transfer happens without any problem. Now let's have a look at the drawbacks. So here in star topology, initial installation cost is very high. They need a central server and they need more cables to connect, to make a connection between the server and the node. More cables are required. Also, if central server, it fails, then whole network goes down. Nothing can happen without their server. Communication will be zero. Requires more cabling compared to the bus topology. Limited maximum distance between the central device and connected devices. So distance is an issue here. Now, how data packets are transferred between two hosts in star topology? Whenever a host wants to transmit data to another host in the star topology, they send their data packets to the central device. Okay, central server. They'll send it to the central server. Packet that is to be sent will have address of the recipient. Sender will transmit packet to the server, right? Server will read address and identifies where recipient is located in the network, and server then transmits packet to the recipient directly. So host sends the data packet to the server. There is address mentioned. Server will check for the address and will locate where the recipient is, and then that data packet will be sent to the recipient. All right. Now comes mesh topology. Here, in mesh topology, there are direct links between all the devices. So all these nodes, they have direct links to each other. So direct communication line is there, as you can see in this picture. So each node is able to connect to any other device in the topology directly. There are different routes, but they can directly communicate. What are the benefits and drawbacks? It is easy to identify where faults are. Fault finding is very easy. Any broken links in the network do not affect other nodes, right? Good privacy and security. Since packets travel along dedicated routes, the network is relatively easy to expand. High fault tolerance, as multiple paths are available. Efficient data transfer, as each device can directly communicate, can handle high amounts of data traffic, and it provides enhanced privacy and security. So these are benefits. You can have a look. When we talk about drawbacks, so large amounts of cabling is needed, right? Each computer, they need a dedicated line, which is expensive and time consuming. Setup and maintenance is difficult and complex. Difficult to manage and maintain as the number of devices and connections increases. Higher hardware requirements due to need for more ports and interfaces. Difficult to scale as adding new devices and connections can become complicated. So one thing is that you can add devices, but as many devices you add, it will become more difficult to manage it. The mesh will become more complex, right? Now, how data packets are transferred between two hosts in mesh topology. So here what happens, when a host wants to transmit data to another host in mesh topology, it sends data packet directly to the destination host. No middleman here. Each host in the mesh topology maintains information about the network's topology and available paths. It is their own task to keep a track of all the available paths. It determines the most efficient path to reach the destination based on this information. The host forwards the data packet to the next hop in the chosen path until it reaches the destination host, right? Intermediate hosts in the path receive the packet and forward it based on the routing decisions. You will learn about all the path calculation algorithms later when we start with A-level curriculum, right? So yeah, routing algorithms and finding shortest path, etc. Now, host forwards the data packet to the next hop in the chosen path until it reaches the destination host. Intermediate hosts in the path receive the packet and forward it based on the routing decisions. Destination, once it receives the data packet, then it processes it according to the protocol. If required, it generates an acknowledgement packet and confirm the successful receipt of the data. Transmission completion, once it is complete, the host in the mesh topology remains available for direct communication with other hosts, right? So that's how communication happens in mesh topology. Now, hybrid topology. So hybrid topology is basically combination of different topologies in one network, right? So maybe some computers are directly computed to this is basically a star. This is basically a bus with a star. So this is central cable. Here, one computer, one node is connected to the central cable. Here, another, a star computer, star topology. Here also another star topology. Here also another star topology. And here also another star topology is connected to the central hub. So this is a bus with a star. So there can be multiple topologies used in hybrid topologies. So basically, it is a combination of different topologies under one network. So what are the benefits here of using hybrid topology? What are the benefits? They can handle large volumes of traffic. It is easy to identify where a network fault has occurred. They are very well suited for the creation of larger networks. provides flexibility in designing networks by combining advantages of multiple topologies, offers scalability. You can handle a larger number of devices, can accommodate different types of network requirements within a single network. And drawbacks, if we talk about drawbacks of hybrid topology, complexity in design, higher costs due to the combination of different topologies and additional hardware requirements. It requires more expertise to manage and troubleshoot compared to individual topologies. Potential for increased points of failure due to combination of multiple topologies. So that is, these are benefits and drawbacks of hybrid topology. Next, how data packets are transferred between two hosts in hybrid topology. So here what happens? Transfer of data packets in hybrid topology depends on specific combination of topologies used. So there are multiple underneath topologies which are there, maybe star, maybe mesh, maybe other topologies which are there. So for example, if a hybrid topology consists of a central switch connecting multiple hosts in a star topology, and those switches are interconnected using a mesh topology backbone, the data transfer would follow the steps described for the star topology within each star segment, and then utilize the mesh topology for routing the data between the different star segments. So depending upon what topologies are there in the hybrid, accordingly, data packets will be transferred in hybrid topology. Now, there is also one topic that justify use of particular topology in a given scenario. So bus topology is suitable for small office with budget constraints, right? So if you are given a situation where office is small and there are budget constraints, you can suggest bus topology. Star topology would be suitable for a small office with a limited number of devices and where more security is required. Mesh topology would be suitable for a large data center with high traffic requirements, and hybrid topology would be suitable for a distributed network with multiple branch offices. So accordingly, you can pick a solution to the given scenario. Now, there are some past paper questions. So first question is from specimen paper 2021. Question is, the LAN has a range of different topologies. One subnetwork connects 4 computers and one server set up as a star topology. Describe how packets are transmitted between 2 of the computers in the subnetwork. So here topology is star. So how data packets are transmitted in star topology, that you have to write. So firstly, each packet has address of, it is of 3 marks, right? So you have to write accordingly. You have to prioritize your points accordingly. So packets, they have address of the recipient. Sender transmits packet to the server. Server reads address and identifies where recipient is located, and server then transmits packets to the recipient directly. So these 4 points, you will get 3 marks, right? Then there is a question in October-November 2022. A local area network consists of 4 computers, 1 server and a switch. The LAN uses a star topology. Complete the following diagram to show how the hardware is connected. So if it is a star topology, so of course your computers will be connected directly to the server or the switch, right? And then switch. Either your computers can be directly connected to switch and then switch is directly connected to server, or all the computers, they can be directly connected to the server. You will get full mark in both ways, right? So you have to just draw lines from each computer to either to switch or to server. So that's all for today. Today we have covered all the topologies and how data packets are transferred between 2 computers of a given topology and justify the use of topology for a given situation. So thank you so much.